Okay, so today we're going to talk about solving systems of linear equations by graphing. Basically what we're talking about here is taking two linear equations, such as y equals x plus 5 and y equals negative 4x, graphing them on the same coordinate plane and just seeing where they intersect. And at that intersection point, what we can say is that that is the one solution that will work for both of these linear equations. So I'm just going to go ahead and make my my coordinate plane. Don't forget, I know it's been a while maybe, make sure you're using your ruler. Starting with our first equation up here, we can see that we've got a y-intercept of 5, 1, 2, 3, 4, 5, and a slope of a positive 1. So I'll go 1 up and 1 down, and that'll allow me to properly set my ruler so that I can have as accurate a line as possible. This is when it becomes pretty important to be using this ruler, because you're looking for a point, and you can see I'm kind of just slightly off, but hopefully it'll work okay. I keep twisting this. Our second line, y equals negative 4x, is going to go through origin, excuse me, it's been a bit, and we have a slope that is negative 4, so I can either go up 4, 1, 2, 3, 4, and left 1, which puts me right on the point, or I can go down 4, 1, 2, 3, 4, and right 1. And now I will just go ahead and connect these dots, and obviously we can see that my solution point is right here. So the solution that will work for both of these is going to be negative 1, 1, 2, 3, 4, negative 1, 4. And so when we are talking about solving these systems, this is the solution to that system of equations. You can even do this with 3 lines, as long as all 3 are going to intersect at exactly 1 point. So it's just a matter of putting all of the lines on one graph to find that solution by graphing. If we are looking at, let's look at another possibility here. Let's say we have, let me find a good equation here that we can solve. Let's say we've got, and let me move this up a little bit so that you can actually see what I'm doing. Y equals negative 2x plus 1. Y equals negative 2x minus 1. Now, on some of these, hopefully you could just look at them and see what is most probably going to happen here. But we'll go ahead and graph them anyway. I just want to show you that there are other options. The first one, positive 1, is our y-intercept with a slope of negative 2. So I'm going to go up to left 1, down to right 1, and I will connect these. And this is just so that you can have this visual. The second one has a y-intercept of negative 1, and also with the same slope. So hopefully from our section on parallel lines, you will see that quite obviously these are going to be parallel lines, and this is based on this slope being the same. And if we recall from our last unit, 2 lines that have the same slope will be parallel lines, and so now graphing it, we can see that. Now we also have a possibility, so that would be a solution with, well, no solution. So, so we would just call that no solution because they're parallel, they will never meet. Let's say we have, let's see, y equals 1/5 x plus 9, and 5y equals x plus 45. Now, excuse me. This one we can go ahead and just straight out graph. So I'm going to go ahead and build my coordinate plane. Let's do it over here so that I have some calculation room over there. So here's my coordinate plane. I'm going to graph the first one. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Ooh, just make it. And my slope is positive 1/5. So I'm going to go down and negative. So 1, 2, 3, 4, 5. Rise over run. 1, 2, 3, 4, 5. Very shallow graph, if you will. So here is the graph of the first line, and now what I'm noting is that this line is not in any form that we work with. So so what I'm going to have to do is I'm going to have to convert so that I have it in one of the forms, be it either standard form or slope-intercept form. So I'm going to have to take that 5y equals x plus 45. I'm going to have to divide everything by 5, and hopefully you'll see pretty quickly that what we have here is exactly the same line. This is exactly the same as this, okay? And this is called infinitely many solutions. So, infinitely many solutions. They're the same line, so anything you pick would be the same. So this is all there is to solving these systems with graphing. So yeah, no bells and whistles. I didn't bring in any anything strange for you today. I hope that's okay. Okay.